This is question number 5 from the Open Education Resources OpenStax textbook. We are given a reaction, 2A going to 2B, and we have various times of reaction and the concentration of reactant A, and we're asked to determine the average rate of disappearance of A between 0.0 seconds and 10.0 seconds, as well as between 10 and 20 seconds. So we first want to write out what the rate is equal to. The rate of this chemical reaction is equal to the change in concentration of A over 2 times the change in time. Now there's a negative sign here because this is a reactant. Reactants decrease in concentration, so there's a negative sign here so that we get a positive quantity for the rate. And there's a number 2 here in the denominator because 2A is going to B. So this is how we calculate the rate for the chemical reaction. Now what we do here is we calculate the difference. Delta is always final minus initial. So we have 10 seconds as the final time, so that concentration is 0.625 molar. And the initial time is 0 seconds, and that corresponds to a concentration of 1.0 molar. All that's going to be divided by the change in time. That's final minus initial. It's 10 seconds at the final time and 0 seconds at the initial time. So if we grab our calculator here, what we get is negative 0.375 divided by 20. The units here are molarity on top, and the purpose of this negative sign is now apparent. We have this here so that we convert this ratio into a positive quantity. So if we calculate this ratio, we get a value of 0.01875. The units here are molarity per second, and of course we would want to round this off to 3 sig figs here. So that's the average rate of the chemical reaction. We can do the same thing here for the difference between 20 seconds and 10 seconds. We go ahead and once again use this formula. And so the change in concentration is final minus initial. The final concentration is 0.370 molarity, and at a time of 10 seconds the concentration is 0.625 molar, and all of that's going to be divided by 2 times the change in time. The time changes from a final time is 20 seconds and the initial time is 10 seconds. So up on top we'll have a negative number, down on the bottom we'll have a positive, and we have this negative sign to change it to a positive overall rate. So this is equal to negative 0.255 molar on top, and down the bottom you can see how it should be 20.0 seconds. If you divide these, you get a value of, again, these negative signs take care of the negative quantity. We get a value of 0.0128 molarity per second when you round that off to 3 sig figs. Like the video if it's to your liking. Thanks for watching.